Dear students, welcome to the problem solving sessions on one-dimensional heat equation. Today we are going to solve problem on type 2. What is type 2? If the steady state conditions and zero boundary conditions are given. Let us go into the problem. In our previous problem, they have directly given ut is equal to alpha square u double x and they give the two boundary conditions and one initial condition. So they give this three data and they tell us to find the steady state temperature function. But now in today's session, we are going to see if the problem is with steady state condition and zero boundary conditions. In steady state condition, my third initial condition u of x comma 0 will not be given directly. We have to find from the question. It will be a theoretical question. We have to identify that the question is zero boundary or non-zero boundary with steady state conditions. Let us read the question first. A rod of 30 centimeter length. So my L is equal to 30. This is the first information. Now it is kept at 20 degrees Celsius, 80 degrees Celsius respectively until steady state condition prevails. So that means this is a steady state problem. Then the temperature at each end is suddenly reduced to 0 degrees Celsius. So from 20 degrees Celsius one end and 80 degrees Celsius other end, it is reduced to 0 degree Celsius. So that means the steady state is reduced to zero boundary condition. Therefore, this is a problem on steady state condition and zero boundary condition. Now we have to find the u of x comma t taking x equal to 0 at the point A. As I said some hints here, the length of the rod is given as 30 centimeter. Never solve the problem with number 30 because we are all habituated with solving either cos nx or cos n pi x by L, sin nx or sin n pi x by L. So assume that L equal to 30 and solve the problem for L. At the end of the problem, substitute the value 30. It will be more convenient and more safer for you to do the problem in a correct way. Okay, let us go into the problem. Step 1. Step 1 is my diagram. One end is A, the other end is B. According to the problem, the first end is given as x equal to 0. The other end is given as 30. Length is equal to 30 centimeter. Now the temperature function can be written as u of x comma t. So the basic assumptions are simple. It is thermally insulated at the sides. Now the temperature given at one end is 20 degrees Celsius and the other end is 80 degrees Celsius. After that, the temperature is suddenly reduced to 0 degrees Celsius. Here also it is reduced to 0 degree Celsius. So now my T1 is going to be 20 degrees Celsius and T2 is going to be 80 degrees Celsius. Now since the temperature is reduced to 0 degrees Celsius, we would say u of 0 comma t is 0. U of 30, I am going to assume this 30 as L. So L comma t equal to 0. So my diagram gets over. This is my step 1. Now in steady state problem, the first two boundary conditions we can identify from the figure. And the third boundary condition would not be given. You have to find by yourself using the words steady state condition. Now we know at steady state u is equal to ax plus b. And I gave the direct formula how to find this u. U is equal to T2 minus T1 by L into x plus T1. From the figure, it is very clear that my T2 is 80, T1 is 20, L is 30. So my u is going to be 80 minus 20 by 30, that is 2x plus T1 is 20. So this is my third initial condition. So now we found all the three conditions from the given question. Now let us proceed. You can see the typed version. Step 2, as usual, step 2, ut is equal to alpha square u double x, where alpha square is equal to kappa divided by rho c, that is thermal conductivity divided by density into specific heat. Step 3, the most suitable solution is known to as A cos lambda x plus B sin lambda x e power minus alpha square lambda square t. The boundary conditions and initial conditions we get from the figure. The first two boundary conditions are u of 0 comma t equal to 0, u of L comma t equal to 0. As I said, I am taking 30 centimeter as L. Only to find the third condition, I am using L equal to 30 in step 1. See here alone I am substituting L equal to 30. But in the whole problem, I am going to take this 30 centimeter as L except this place. Therefore, my second boundary condition is u of L comma t equal to 0, which make me very sophisticated to solve the problem. Then the initial condition is u of x comma 0, 2x plus 20, where x lies between 0 to L. Now, as usual, 1 in 1. If I put u of 0 comma t equal to 0 in 1, we will be getting 0 is equal to a e power minus lambda square alpha square t. Since this is not equal to 0, because if this is 0, my equation 1 will become 0. That is not possible. Therefore, a equal to 0. Substitute a equal to 0 in 1, we will be getting a new equation 2. Now substitute u of L comma t equal to 0 in equation 2. We will be getting 0 is equal to b into sine lambda L into e power minus lambda square alpha square t. And it is very clear that this term cannot be 0 and b also cannot be 0. Why? Already we prove a equal to 0. Suppose if you take b is also 0, then the equation will become 0 plus 0. 0 into anything, you will be getting 0. So there is no chance. So b is not equal to 0. Therefore, the only choice is sine lambda L is equal to 0. And we know that if sine lambda L is equal to 0, then sine n pi is also equal to 0. Now comparing sine lambda L equal to 0 and sine n pi equal to 0, when n belong to integer, we will be getting sine lambda L is equal to sine n pi. When sine get cancelled, we will have lambda L equal to n pi and finally lambda equal to n pi by L. Now substituting this lambda equal to n pi by L in 2, will be getting like this. As I said earlier, in heat equation, we have 3 boundary condition. So my equation 3 is always most general solution. In my wave equation, I have 4 boundary condition and equation 4 should be my most general solution. So I am taking b is equal to bn and my most general solution is depicted in the image. Take it as equation 3. Now apply the third boundary condition u of x comma 0, that is 2x plus 20 in 3. So we take in general u of x comma 0 is f of x. When we apply, we'll be getting like this. Since e power 0 is 1, when I put this value, my t equal to 0, I'll be getting this equation and u of x comma 0 is my f of x. Now it looks like my half range Fourier sine series. So we'll take the formula for half range Fourier sine series. Now we have to find bn, where bn is equal to 2 by L integral 0 to L. My f of x is 2x plus 20 sine n pi x by L dx. And what is the good thing in steady state conditions and zero boundary condition problem? My f of x is always going to be sum ax plus b. So the power of x is 1. The integration is very simple for bn. That is the advantage. Now let us integrate this and substituting in equation 3 will give the final solution. We are going to integrate using Bernoulli's formula uv minus u dash v1 plus u double dash v2 etc. Now I'll take u as 2x plus 20, my diminishing function. U dash is 2, u double dash is 0. dv is equal to sine n pi x by L dx, and integrating this will be getting minus cos n pi x by L divided by n pi by L. And v1 is going to be minus sine n pi x by L divided by n pi by L whole square. Now mapping uv and u dash v1, remaining all the terms will become 0. I can find the answer for bn. Therefore, my Bn is equal to 2 by L 2x plus 20 minus cos n pi x by L divided by n pi by L minus 2 into minus sin n pi x by L divided by n pi by L whole square, and my limits are 0 to L. As usual, the sin term will become 0, only cos term survives. So Bn is equal to, I'll take this minus outside, minus 2 by L, and the denominator to the numerator L by n pi, and we have 2x plus 20 cos n pi x by L. My limit is 0 comma L. Now substituting the upper and lower limits, will be having minus 2 by n pi, upper limit is L, will be getting 2L plus 20 cos n pi minus lower limit is 0, so 2x will become 0, 20 into cos 0. Therefore, Bn is equal to minus 2 by n pi. We know that cos n pi is minus 1 whole power n, 2L plus 20 minus 20. Now you see, students, put L equal to 30 here. If you start doing the problem with 30, lot of confusions will come in the integration and substituting the number. So always better go with L. At the end of the problem, substitute the L value. Now Bn is going to be minus 2 by n pi. When I put L equal to 30, I'll be getting 80 minus 1 whole power n minus 20. Therefore, multiplying the minus inside, will be having 2 by n pi, 20 minus 80 minus 1 whole power n. Now, taking 20 outside, we'll be getting 2 into 20 divided by n pi, 1 minus 4 times minus 1 whole power n. Therefore, my Bn is going to be 40 by n pi into 1 minus 4 times minus 1 whole power n. So this is the simplest way, guys. Take the given data as L, solve it, and at the end substitute it to get the Bn value. Now finally substitute Bn in my most general solution to get the answer. U of x comma t is equal to summation n equal to 1 to infinity Bn sin n pi x by L e power minus n square pi square alpha square t by L square. Now we know that L value is 30. So L square is going to be 900. Substitute the final value here. So finally I can write my answer as U of x comma t. I'll take this 40 by pi outside because it is a constant. N equal to 1 to infinity. I'll be having 1 minus 1 whole power n divided by n sin n pi x. L is 30. I'm substituting this, and e power minus n square pi square alpha square t divided by L square is 900. This is my final solution. So this is the easiest way to solve this type 2 problems, students. Thanks for watching. Subscribe our channel, share to your friends. Any doubts, you post in the comment box. We are here to help you. See you in the next video. Bye bye.